Welcome you all. This is Preskala from St. Joseph's College for Women, Tirupur. In this presentation, we are going to see about the Hartley Oscillator. Presentation sketch of this is. We are going to see about the oscillators, types of oscillators, principle of oscillator, Hartley oscillator, working method of Hartley oscillator, afterwards feedback fraction of Hartley oscillator. Before going to know about the Hartley oscillator, we should have a knowledge about oscillators. Oscillator is a device. It converts DC signal into AC signal. The components of these oscillators are capacitors, resistors, op-amp, transistors, transformers, etc. And this oscillator is act as a power source in many electrical devices. Types of oscillators. We have two types of oscillator in the electronics. One is linear oscillator or harmonic oscillator. It produces sine wave. And the another one is non-linear oscillator or relaxation oscillator. It produces square wave or triangular wave, etc. Principle of oscillator. Oscillator works based on the principle of positive feedback. Positive feedback means the phase of feedback signal should be in phase with the input signal. What I am telling is, consider a source. I am going to give this source, which means power, to this amplifier. Afterwards, it produces an output, and I am going to take the output to the feedback network, and this feedback network produces an output, and this output should be in phase with our input signal. If it is in phase with our input signal, means that process is called positive feedback. And Hartley oscillator is an oscillator. It was produced by American engineer Ralph Hartley in the year of 1915. The components of Hartley oscillators are potential divider, power supply, transistor, tank circuit, coupling capacitor, etc. Circuit operation of this Hartley oscillator is fully based on two circuits, that are tank circuit and feedback circuit. This is a transistor and this one is a feedback circuit. Circuit diagram of this oscillator is, initially we have power supply plus VCC and RF choke, tank circuit, transistor with common emitter, and afterwards emitter resistance, emitter capacitance, coupling capacitance, C out and C in are coupling capacitors, R1 and R2 are potential divider. That's all. Working method of the Hartley oscillator is, initially we have to energize our capacitor with the help of plus VCC. Afterwards, this capacitor discharge, it produces charges, which means electrons to the inductance L1 and L2. L1 and L2 are a coil, and it produces mutual inductance between each other. Afterwards, this coil produces back EMF. So because of that, we will get an output. the output may be a sine wave, and we can get the output in this terminal, and the output is fed back to the transistor, and the transistor produce one more output in the Cout region. So this output should be in phase with the input signal comes from the plus VCC. If once we get a whole cycle, means afterwards there is no need of plus VCC, we can switch off this plus VCC. So once we can get the output from Cout, means afterwards it produce a supply to the capacitor, and the capacitor charge discharge process happen. Afterwards L1 and L2 conduct each other, and it produce mutual inductance and back EMF. Afterwards from this tank circuit we will get an output, and this output is fed back to the transistor, and afterwards transistor produce one more input, and this happens continuously, and finally it produce continuous sine wave, which means continuous undamped oscillations. This is the working method. First initially we have to energize our capacitor, and the L1 we will get an output from the L1 terminal. The feedback voltage we can get from L2 terminal. So L2 output should be out of phase with the L1 output, which means they both should have different phase. And afterwards finally we will get 180-degree phase shift with the help of transistor action, and L1 and L2 coil. Frequency of this oscillation is fully depends upon coil L1, L2 and capacitor C, which means tank circuit. So frequency F is equal to 1 by 2 pi root of C L T. LT is equal to L1 plus L2 plus 2M. L1 is a coil, L2 is a coil, 2M is a mutual inductance between two coils. We can get our feedback voltage at the L2 terminal and the output voltage at the L1 terminal. So the feedback fraction is MV. So MV is called as a feedback fraction. MV is equal to VF divided by Vout, which means output voltage, voltage from the feedback divided by voltage from the output terminal. So we can write these two into XL2 divided by XL1. XL2 divided by XL1 is called as a inductive reactance of coil L2 and coil L1. Inductive reactance means it is a kind of resistance exists in the inductance coil. So this L2 and L1 we can write these two into L2 by L1. So finally feedback fraction is equal to L2 by L1. The fraction of feedback from the L2 terminal is it should be the fraction of L2 and L1. Thank you all. We will meet in our next presentation.